Hello and welcome to Let's Hit the Road Jack, a building information modeling workflow for roads and highways. My name's Michelle Rasmussen and I'll be the tour guide today. I do apologize that I wasn't able to give this live at AU, but I'm excited for the opportunity to at least present it now as a recording. So just a little bit about me. I have been using AutoCAD since release 9, and I've been teaching the Autodesk products since 2000. I have been writing courseware for Ascent since 2007 and working with RAND Worldwide since 2006. I am an Autodesk certified instructor as well as an Autodesk Infrastructure Design Suite certified BIM specialist for the roads and highway solution. So here's just a quick summary of the class. I'll be taking you through a workflow for roads and highways that will take you through the Infrastructure Design Suite as well as InfraWorks 360 software for the conceptual and preliminary design phases. And we'll basically use the Roadway Design for InfraWorks 360 software to perform industry-specific optimization of the road design. Then we'll move that design into Civil 3D and take it through the construction documentation phase and the detailed design. And then we'll take it into Navisworks where we'll be able to perform some clash detections, and we'll finish it off with bringing it back into InfraWorks and into 3ds Max design software to perform the visual communication about the design to the key stakeholders. So a couple key things that you'll be learning. You'll learn how to sketch layouts and create engineered roads of the proposed design in InfraWorks 360 software. You'll also learn how to create detailed design drawings inside AutoCAD Civil 3D software, and then learn how to analyze the design in Road Design for InfraWorks 360 and in Navisworks Manage, and then finally communicate the design visually with InfraWorks 360 and 3ds Max design software. So let's get started. Building information modeling is not a specific software program. It's a streamlined process that allows us to make better decisions about project design based on reliable information analysis. And we do that with extremely data-rich models. And we use those models from the project planning phase all the way through the preliminary design, detailed design, and design communication. And by doing that, it allows us to reduce rework, and it helps engineers make better predictions about a project's performance, increasing the safety, constructability, and sustainability before it's even built. And this allows for better decision-making and more economic project delivery. Through using the high-impact visuals that you get from InfraWorks and 3ds Max design, we'll be able to better communicate the design to key stakeholders, the government agencies approving it, as well as the general public, to help reduce construction delay costs. So a little bit more detail on the workflow. Basically, the Infrastructure Design Suite software portfolio is a combination of powerful building information modeling software, and it streamlines the workflow of infrastructure projects with a 3D model, and you'll use the same model throughout the process. First off, you might be asking yourself, how is that workflow different than a traditional workflow? It looks the same. Well, the difference really is in where you're going to reduce costs. When you have the ability to impact the cost and performance of a project early on, the cost of making design changes is reduced as you get into construction and operation. But when there's a drafting-centric workflow, you'll see that your cost of making changes is really in that construction documentation phase, and you want to reduce that. If you can do a little bit more work in the preliminary design phase and the detailed design phase, then the cost of making changes is reduced during the construction documentation, the construction and the operation phases. So what does that look like? The recommended workflow is that you'll start with Autodesk InfraWorks 360 to build data-rich models. And then you'll take that data-rich model and reduce rework by pulling it into Civil 3D and Navisworks Manage. And by using the same model, you're not having to redo a lot. And then finally, you'll take it back into InfraWorks 360 and 3ds Max Design for those high-impact visuals. There's some key things when you're creating your data-rich models that you need to be aware of. First off, working with geographic information systems. Basically, today's infrastructure planners are expected to evaluate multiple design alternatives, recommend better solutions, and help capture stakeholder buy-in before design even begins. And they do this by using those data-rich models that come from geographic information systems. The information is now available from more sources than ever, and GIS professionals need to be able to effectively aggregate and present the data in a way that's easily understood. Unfortunately, not all of the data that you're getting from other professionals are in the same coordinate system, so it's extremely important to communicate to the software what projection system the information is in. That way, it can automatically be reprojected as it comes across. And the difference between the projection systems can be huge. You'll see that I have 3 different coordinate systems here, and right at the center point where that data is aggregated, it's pretty accurate, but as you get further and further out, it becomes less and less accurate and it doesn't line up as well. So that's why it's extremely important to make sure you have the projection system set before you even begin. Now, setting up the project coordinate system does not change the units that you see in the model. That's because when you're working with Autodesk InfraWorks, the units are unitless. And what you do is you set the units that you want to see in the model. And so we can do that very easily by going into the settings and utilities and then bringing up the application options. So let's actually see how this is done in the software. To create a new model, on the home screen, click New under the Model area. The New Model dialog box will appear. This is where you will set the location and the name of the model. Then you can define the extents. By defining the extents, you can reduce the size of the model from the beginning. Of course, you do need to know a little bit about the model to be able to set extents at the very beginning. Otherwise, you can go back in and set the extents after the fact. And then, of course, you do need to set the advanced settings where you'll set the coordinate system. And when you click the globe, you'll see all the coordinate systems for the entire world. If you click the down arrow, you'll see coordinate systems that you've used most recently. Then finally, you can set design standards. This is going to come into effect when you start making design roads so that you have the correct standards according to where you are. Once the new model is created, you'll see the model extents, which is a gray area in your model window. Then you'll want to go and set the units for the model, because even though you've set the coordinate system, it did not set the units. So I'll go to the settings and utilities and choose application options. Then on the units configuration screen, I'll set the units either to imperial or metric. Now we're ready to start creating a model. Now that we have a model created, we can start effectively aggregating the data from various types. And both InfraWorks 360 and AutoCAD Civil 3D can integrate data from many different sources. Any model must start with a surface or terrain data when you're working with InfraWorks. And so you'll start by adding in either a raster file that contains DEM data, digital elevation models, or you can bring in land XML data if you wish. And then you can bring in raster images and road center line data, parcel data, and any other important information from the many different sources that you see on the screen here. There are 2 types of sources that you can bring in. You can bring in file data sources, such as IMX files, Civil 3D drawings, raster files, or you can bring in database files, such as from Oracle databases or SQL servers or any of those. Once you bring the data in, though, you're not going to see it until you actually configure it, because it needs to know what type of data it is. So you'll actually configure the data and then choose the type of information that it comes from. Is it a building model? Is it city furniture or roads? You know, basically what is it that you're bringing across? And when you're bringing in the data and configuring it, you want to map key fields because you have all that rich information behind the line work. You know, when it comes to road center lines, you might have the type of road or the category of road that it falls into. Is it an interstate? Is it a local road? Is it a collector road? What is it? And then you can actually set the elevation of the model as well. You know, the digital elevation models will come in at the correct elevation, but other information you might want to drape on top of that digital elevation model. So, for instance, building footprints, you can bring that in and have it drape right on the model. That way your buildings end up at an elevation, where most building footprints are usually at elevation 0. And then, of course, once you bring it across, you'll want to set up how you want everything to look. And luckily, there's 2 ways you can do that. One way is you can use style rules. The style rules actually look at data behind the information or behind the line work, and it uses that information from the database to actually stylize the model. So if I had roads and I knew that the database had the type of roads listed, then I could stylize it and tell it, show all my interstates as, you know, a nice thick 4-lane highway. Or if my local roads are in there, show my local roads as 2 lanes, you know, both directions, whatever the case might be. But, you know, even when you do have rules that set up all of the styles, sometimes you have to do a style override because there's always exceptions to a rule. And that's because, you know, one road or one building, it doesn't quite fit the style of everything that's going on. And so you'll actually override it using a style palette. So let's learn how to bring the information in, properly configure it, and then display it. To import data, you need to make sure the Data Sources panel is open. Do this by going to the Build, Manage, and Analyze Your Infrastructure Model, then click Create and Manage Your Model. Below that, you'll see the data sources, and that will open a panel or close the panel for the data sources. From the Data Sources panel, you can add database sources or file sources. So I'll expand the file sources, and you can see all the file sources that are available. I'm going to choose a land.xml file to bring in some surface data. So I'll choose that, click Open. Now that that data source is in, I do need to configure it because the status showing not configured, so I'll double click on it. We'll bring up the data configuration dialog box. Since this is the first thing I've brought in, it's wanting to make it automatically a terrain because at the very minimum you need a terrain to work with. So I'll just make sure that it has the correct coordinate system so that it automatically reprojects for me, and close and refresh. Now that I have my terrain, when I look at it from a side view, you can see all the definition where I have a river and other things flowing through there. And I'm ready to start adding additional file source data types. So to do that, again, I go back to the data source panel and choose the type of file that I want to bring in. If I have more than one of the same type of file source, I can use the Shift key to select all of them, or use the Control key to select only certain ones. Either way, I can select multiple files at once and open them, and they will show up in my area here. Then it's just a matter of double-clicking on each one to configure them. Since I do have rivers, I'm going to tell this that it is a water area, set my geolocation, and on the Source tab, I want to make sure that I drape that on the surface. And for this one, I'm going to tell it to use closed polylines as polygons. When I'm done setting all of the features as I need, I hit close and refresh. Now I can see my river running through and other little bodies of water scattered throughout my landscape. Next thing I want to do is I'm going to configure my buildings. So I'm going to double click my buildings, tell it that it's buildings. Then on this one, I want to make sure that I set my roof height. I actually have a field in the database file behind that SDF that tells me how many stories each building is. And I'm going to multiply those stories by 3.1 to set the roof height. So I'm going to click on the expression editor next to roof height and set my stories. Whoops, let me delete that. Now I'll just double click on stories, set my operator to a mathematical operator to multiply it by a value of 3.1 and click OK. And I can set other styles up as I wish, but I do need to make sure my geolocation is set up. It did have a PRJ file associated with that SDF, so it found the coordinate system automatically. But I also want to drape my buildings right on the surface, so I'm going to drape it and then close and refresh. Now the model is starting to look much better, but we need to do some more stylizing and of course bringing in and configuring more information. I'm going to just switch proposals at this point so that I have all of my data sources brought in for time's sake, so that I can show you how to stylize this file. Okay, now that I have all of my data sources brought in, I want to start stylizing it. And first thing I want to do is stylize these buildings. I don't want them to look like plain blocks in my model. I want them to look like real buildings. And so I'm going to close my data source panel, and under the Build, Manage, and Analyze Infrastructure model and Create, Manage, and Your Model, I'm going to open up my style rules. The style rules are available for you to automatically stylize things according to some parameter in that file type. And so if I want to create a new style rule for my buildings, I'm going to simply hit the plus symbol and I'll give it a name and click OK. Then I can double click on that and edit an expression to find the information I want and then give those specific items a style. So let me click Edit for my expression, and this one I'm going to set my roof height to equal a certain value. However, I don't know what value I want specifically, so I'm actually going to use the Get Values panel that's over here. If that's not showing, you simply hit the arrow to the right that hides and shows the value pane. Then I'll look for the value that I want, so my roof height, and it will show me all the available values for that. And I'll simply select one of the values by double-clicking it, and it puts it in the value field. And so my expression has been created. Now I'll simply add a style so that all of my buildings with a roof height of exactly 9.3 will have this specific style. For the offices, I'm going to use a Blackbird style. I'll click OK. And you'll see that nothing has happened. Well, just like with the close and refresh, you can't make it do anything until you close and refresh your data sources. It has to know that you want to run those style rules. So I've actually made other style rules to go along with the single family and small business that I've created. So I'll simply click Run Rules. And now all my buildings have styles, and when I zoom in, you'll see that each one is different according to the type of building that it is. However, this building right here still isn't looking quite right, so I do want to make one more change. I'm going to close my style rules and open up my style palette and find my facade. And I'm just going to drag and drop a new style on top of a building, and that overrides whatever style the rule had set up. And now that looks much better. So when you're setting up a bunch of styles, you can use the rules. One style at a time, you just drag and drop from the style palette. All right, now that we've brought in our existing conditions and brought in a few items, we're ready to start really designing the project. And so before we get too far, though, we need to create additional proposals. Now, you saw me earlier switch between proposals when I started bringing in information, and then I said, well, let's go and look at all that information already brought in, and I switched proposals. But proposals really do provide a way to explore multiple design alternatives within the same model. And by default, every model has a master proposal. The master proposal is the base model. It's recommended that you only populate the master proposal with existing design data. Once the base model has been created and existing data imported, the next step is to create a new proposal for each conceptual design that you want to explore. And then after multiple proposals have been created, you can compare each of them and analyze them to find the best alternative. When you're working with roads inside of a proposal and you've sketched those roads in, you can look at those roads in two different ways. If you've used sketch roads, you can look at them as 3D models, as you see on the right-hand side of your screen, or you can look at them as 2D objects, as you see on the left-hand side of the screen there. And then you can adjust them accordingly using gizmos. So when you start adjusting your roads, you'll see different gizmos depending on what way you're looking at your model. If you're in a plan view, you'll only see control point gizmos, but when you are in a profile view, you'll actually see an elevation gizmo that will allow you to change the height of each of your points of intersection. So let's take a look at sketching some roads inside of the InfraWorks model. You can create a new proposal in two places. One place is in the utility bar at the top. Just click the down arrow next to Switch Active Proposal and select Create New Proposal. You can also see all the proposals by clicking on Proposals under the Create and Manage Your Model area. This opens up the Proposals panel, and from there you can add new proposals and you can see how many items you've added of each item type. I'm going to click plus to add a new proposal and tell it what the name is and click OK. This is going to make a copy of all of the items that are in the current proposal and bring them over into the conceptual proposal. Then you can add and remove items as necessary without affecting the original proposal that it came from. Now that I have a proposal created, I can go in and start sketching my items. So I'm going to go back to the Build, Manage, and Analyze Your Infrastructure model and create conceptual design features, and I'll start at the top and click Roads. I do need to select a style. This gives it the look of the road. I'm going to select one with my sidewalk, a trail, my pavement, my lane markings, and lamps in my road. Then I simply zoom in and start creating my model. If I select on part of another road, it's going to automatically connect to that road. And you can see it's sketching it in a 2D form to begin with. And wherever I left click, it creates a point of horizontal intersection. When I'm ready to end my road, I simply double click where I need it to end. Then you can see that where I've crossed another road, it automatically created an intersection. If I'd like to change that so that it doesn't go beyond the road, I'll have to click Edit on the utility bar, and you can see it gives me my gizmos so that I can make changes. If I select the horizontal grip, I'll simply drag it back to the center line of my road, and it cleans up that intersection. And you'll notice that when I change my view more than 45 degrees, it gives me a different gizmo so that I can actually change the height of my road. But there's a little bit of a problem. When I'm crossing the water, you can see it's trying to suck that elevation of the water right up to the elevation of the road. I probably want to correct that, and I'll do that by splitting the road into two features and telling it to change this piece of the road to a bridge. So I'll just right-click anywhere I want to make a split and select Split Feature. Then I can right-click on the road and select Properties. In the Properties palette, I'll change the manual style to a new style like a bridge. Click OK, but it won't update until I actually tell it in the Properties panel to update. Then I can go about making whatever changes I need to the model. And that's a much better road than the one I originally designed. You may have noticed that as I was sketching the road, I did not add any kind of design constraints to it. That's because sketch roads are really not meant for that. Sketch roads are used to quickly see how a road will look in the model without having to worry about the design constraints like the tangent length and curve radius or anything. The drawback to using a sketch road is that when you take them into Civil 3D, they don't come across very well. In fact, they come across as splines. So rather than having two tangents with a curve in between, you're left with two tangents with multiple small little segments in between, or basically a spline. If you want to add design constraints, you may want to consider using design roads to provide a way to add design constraints to the road. The design constraints that can be used include setting the tangent length, the curve type, whether you use a curve or a spiral curve spiral, and you can set the radius as well as the design speed. And if you have the Autodesk Roadway Design for InfraWorks 360 module, you can also optimize the design road to balance cut and fill quantities. The most beneficial aspect to using design roads, though, is the fact that when you transfer the design road into Civil 3D, you don't lose any of those design constraints. In fact, when you move it into Civil 3D, they become Civil 3D alignments and profile objects. And that allows you to reduce the rework between the preliminary design and the detailed design phases of the project. In the Roadway Design for InfraWorks 360 software, the default design speed is determined by the type of road selected. The types of engineered roads and their default design speeds are shown here. And so if you're looking to create a residential road, maybe going in front of a school or something, you'll probably select either a local road or a collector road for those lower design speeds. However, if you're looking to design something that maybe needs a faster mode of transportation and higher traffic volumes, then you'll probably be looking at using the freeway option. Key is, look at the types of road that you're designing and then determine what the maximum design speed is going to be for your road, and then select the design road that's applicable. Keep in mind, these are the design speeds, not the traveled speeds. So for instance, if I'm designing for a school area, my school zone would only be 20 miles per hour, but I would still use a local road type and design it for 30 miles per hour because my design speed would be a little bit higher than my posted speed. The design speed property of a road determines the default criteria that's available as you start creating your roads with spiral lengths and your maximum or minimum curve radius. As you create the design road, you have the option to adjust the type of curve being used and its radius within a set parameters that are determined by the design speed. So for instance, you can see here, this gray area means that I cannot set my curve any smaller radius than the number that's just before that gray area. And I can't go beyond the maximum either. Design roads can be edited using a variety of methods. Just like with sketch roads, design roads have gizmos that can be used to modify the design. You can also use the design road asset card and a profile view to help you modify the road. Vertical optimization is used to automatically compare costs and environmental impacts on multiple vertical designs. Once a rough horizontal and vertical design geometry has been drawn in the model, vertical optimization can be calculated to produce multiple vertical design options based on parameters that you enter in the calculator. The optimization parameters that can be entered in the calculator include setting specific constraints like the maximum grade and the minimum PVI spacing. Of course, you can set which PVIs are anchored to match certain elevations at specific stations. You can also add borrow and waste pits if you'd like to help reduce mess hall costs. And then finally, you can actually include the local cost parameters in your calculations so that you get a much more accurate calculation. So let's take a look at design roads and optimizing the design inside of the InfraWorks software. The Autodesk Roadway Design for InfraWorks 360 module is a cloud-based add-on that enables you to add engineering parameters to road designs. You'll know if you have this module if you see the icon to design, review, and engineer roads. If you do, just expand that, then expand Design Roadways, and you'll see the 4 different options for the types of roads you can design, according to the design speed you need. I'm going to select Collector Roads, then select a style from the Style palette and close my Style palette. In the model, I'll simply left-click to start the road. Then at my cursor, you'll notice that I can set the design speed. By default, it is at 60 kilometers per hour because I chose a collector road. If I tab twice, it allows me to type in a length and hit enter, and that will lock in that length, and you'll notice that then I can left-click to set the bearing of that first tangent. Once that first tangent is set, I can move my cursor and you'll see a curve appear. When I right-click, I can set my curve radius by changing it in the curve options, or I can change it to a spiral curve spiral, and again I can right-click and change the curve options there. This time I have the option to set spiral lengths and a curve radius. You'll notice that in my model that the curve is blue and the spirals are orange. I'm going to set mine back to a curve and just complete putting in my roadway here. Oops. When I'm ready to end the road, I simply double-click to end it just like I would sketch roads, or I can left-click and then right-click and select End Draw. When it's done, it's going to show me all of the road according to the parameters that I had set up. If you'd like to see the gizmos to be able to edit it, the edit mode must be set to geometry. That will show me my gizmos. I'm just going to move my asset card a little bit more out of the way because we are going to come back to that. And then when I change my model view from a plan view to more than 45 degrees to the profile view, you'll notice the gizmos change. That's because it's changed to vertical gizmos. And so this gizmo right here, that's a vertical curve or vertical intersection. I can move it only in one direction. So if I select it and I start moving it to the right or left, it's only going to change the station of that PVI. And if I'd like to change the elevation, I can select it again and this time move it up or down. If I start typing in an elevation, I can set the elevation at a specific height, or I can just go ahead and move the cursor to set that height. Now, one thing you'll notice, let me just zoom in here, I have the Autodesk Bridge Design for InfraWorks 360 module. So where that road crossed a waterway, it automatically put in a bridge. This is a really nice feature to help speed up the design of roads across waterways and other ravines. So one other thing that you can do is when you are in a vertical view in the model, you can right-click on any of the vertical points of geometry or the gizmos, and then you can show that road in a profile view. That opens a profile view dialog box below, and then I can right-click in there and add additional PVIs. I could have right-clicked in the model to add PVIs, whatever the case might be, wherever I need to add those. And then I can make modifications to them in either the profile view or in the model view, wherever it needs. And of course I can change my vertical curve length by just making changes to the model. One other thing that you might be aware of is in the asset card, you can change the edit mode to styles to change the style of the road at certain sections, how many lanes you have in the right lane or left lane, forward or back, and you can change the grading. So right now, you can see my grading. Let me get into a better view here so you can see it better. My grading is going out at a specific angle. That's because I have a fixed width grading. It's going out a fixed width and then just finding interpolation between the top of the road and where that fixed width is, and just doing a straight shot or a straight grading slope at that. If I'd like a very specific grading slope to make sure I don't go beyond what is required, I can change it from a fixed width to a fixed slope, and then I can set the cut slope separate from my fill slope, and you'll notice that it goes out that 3:1 slope up to the grading limit, and then it will cut off. If I need to change that grading limit, I just type in a new number there and it will adjust accordingly. So let me set it back to my geometry edit mode so that we can make sure we can do everything we need to. And now I'm ready to go in and optimize that road to make sure that I have a good vertical elevation designed. To do my vertical optimization, I go back to my Design, Review, and Engineer Roads, and then Review and Modify Roadway Designs. And I'll make sure that I choose the Profile Optimization. This is going to open up another dialog box over on the right-hand side. This is going to say that I'm working on Design Road 1. I can change my design speed here, and what kind of structure do I want. I'm going to use my road style. And when I go to the advanced settings, this is where I can set all of my profile constraints. So I can set a maximum grade. Maybe my maximum grade is 8%. My minimum PVI spacing, my drainage required, and I can go in and add in anchors to my PVIs. So this is great if I need to make sure that that bridge stays a certain height over the water. I can easily set that. So that would be the 4th PVI, and so that's anchored, and so it won't move, but the others will. Then I can go into my quantity options and add any borrow or waste pits to help reduce the construction costs. I can also go into my construction rules and tell it wherever there's a maximum fill height of more than 10 meters, I can have it create a bridge, or where there's cut more than 20 meters, I can have it automatically create a tunnel for us. And I can go in and change my construction and earthwork costs by clicking Construction and Earthwork Costs. It's going to bring up a dialog box. This is saved out in the cloud, so I can change this once and then change it however often as I need to. If I want to set a 500 meter free haul distance, it will help calculate the hauling cost to bring dirt into the site according to our needs and according to how much cut and fill we have. And I can change any of the other costs associated with the roadway according to the local costs of where that road is going to be built. And I click OK. When I'm all ready, I have everything done, I just go back into my profile optimization dialog box and hit optimize. And it's going to go out and send this out to the cloud. It will require 100 credits, you saw show up right there, and I let it optimize, and when it's done, it will bring open the optimization palette, or the job monitor palette, which you could have opened from the Review and Modify Road Designs under Job Monitor. But from here, I can go in and tell it which profile to bring across. Now, I've already brought in some other profiles, or I've analyzed this previously, and so I can actually go in and tell it to create a proposal of the new result. And so it will create a whole new proposal within my model. So up here, this would become a new proposal, and it would bring that new roadway in according to the design parameters. Now, if I'd like to just look at it before I bring that in, I can look at the optimization report, and it'll show me a sample of what the profile will look like. It'll tell me my total project cost, and you can go through and just read through that entire report. The next thing we're going to do is look at how a BIM workflow helps reduce rework. And now, up to this point, we have done everything for the conceptual and preliminary design phases in InfraWorks 360. But we're ready to take it into a detailed design phase where we're going to take that InfraWorks model into Civil 3D software so that we have our alignment and profile from InfraWorks, and we can pick up right there and start creating our corridor model and cutting plan and profile sheets. Beyond that, we'll also want to analyze the design, and we'll use Navisworks Manage software to analyze the road design compared to Revit model, maybe from the architect, and we'll combine those two together in Navisworks so that we can do a clash detection and make sure that everything is coordinated properly. When you're ready to take the model from InfraWorks to Civil 3D, you're going to expand the Settings and Utilities icon and select Export IMX. When you're in the Export IMX dialog box, though, I want to caution you on what you take into Civil 3D. If you allow it to take the entire model, it's going to take all of that GIS information that you imported from other sources and take it over into Civil 3D. That's not a bad thing, but it's not a good thing either. The reason is it's going to make your Civil 3D drawing file much, much larger if you import that information. It's actually better to use the map commands within Civil 3D to connect to the GIS information so that it acts more like an XREF and it reduces the size of your drawing files. So what I recommend is when you're exporting the IMX, use either a bounding box or a polygon like you see on the left side of your screen to wrap just the information that you need. Then when you take it into Civil 3D, you'll choose the Insert tab, Import Panel, and select IMX. Then you'll go ahead and create the detailed design in Civil 3D without missing a beat. Once in Civil 3D, you'll create your assemblies so that you have your typical cross sections of your roads, and you'll add it to a corridor using the InfraWorks alignment and profile to create that corridor with the new assemblies. Due to the short length of this class, we will not go into the details on how to do this. Just make sure that you understand how to add additional baselines, which are alignments, additional regions, which are assemblies, and targets, which set transitions and daylights for your corridor model. That way you have a complete model. Then, when you round trip the model back to InfraWorks, you'll be able to show stakeholders what the design really looks like, even if you've made changes to the detailed design. That way it makes it much easier for the general public to understand what the design will look like when you're done. So let's actually take the design into Civil 3D at this point. Okay, now that I have a nicely optimized profile for my road, I'm ready to take that design into Civil 3D to then do the detailed design and create my plan production drawings. So to do that, I'm going to go into the Settings and Utilities area and select Export IMX. Now I'm going to warn you against taking the entire model when you do this, because if you do that, it takes all of those buildings and brings those across. It takes all of the roads, the existing roadways, and brings those across. It takes everything out of this model. So I'm going to highly recommend that you do a bounding box or a polygon. To do the polygon, you just select it from the list and then go in and define a region that you want to bring across. And I'm going to make a nice little polygon around my road that I've designed, making sure that I grab far enough out that it grabs the daylight lines and everything. And when I'm done, I double click to end it, and you can see it grabbed my minimum maximum areas. I also need to set a target coordinate system so that it knows how to line them up when I bring it into Civil 3D. And I'll choose a location for that. Mine's just going to go to the users, M. Rasmussen, and then the IM export. I'll click export, and it says, oh, that already exists because I've done this a couple of times, and I'll just hit replace it. And now that it's out there, I'm ready to go into Civil 3D, into my existing conditions drawing that already has, all of that line work that I want in there. So it's just a matter of inserting that. So I go to the Insert tab. On the Import panel, I click Import IMX. And you can see it's at the correct location. And so I'll choose the IMX, and click Open. And now I'm ready to go in and start doing the detailed design work. So the nice thing about this is on the Prospector tab, when I expand my alignments, you can see that my alignment is already there and it has a profile already assigned to it. So it's just a matter of creating that profile view and creating the finished, actually we have the finished ground profile, which is this one. It's just a matter of sampling the existing ground profile from the survey data and creating that profile view, and then finishing up the line work, going in, creating your corridor and everything like that. The Autodesk Navisworks Manage software makes design review much easier by providing the opportunity to open up multiple file types in one software and then running a clash detection across them. When we're taking a Civil 3D model and we're opening it in Navisworks, most of the time that works just fine. If you happen to have any problems though, you can open the file up in Civil 3D and export it to an NWC file, which is a Navisworks clash file. Once it's in Navisworks, you can append additional files to it so that you can run a clash detection later. And when you're appending a Revit architecture file, you'll know that it doesn't always line up properly. That's because most architects will have their Revit model based at 0, 0, and most civil firms will have their files based at the real coordinates in the real world coordinates. And so you will need to set the file units and transform the files so that they line up properly. Once they're all lined up, you can go in and perform a clash detection. Basically, the clash detective identifies, inspects, and reports interference clashes in a 3D project model. Clash detective can automate the manual task of checking for clash errors, and you can use it for a quick check of design work that an engineer has just completed, or for ongoing audit checks of the project throughout the project process. This can be done easily by a project coordinator. You have the ability to do one of 3 types of clashes. You can do a hard clash, which is where 2 objects actually intersect. You can do a clearance check, where 2 objects come within a specified distance of each other, or you can even check for duplicates, where 2 objects are identical and for both type and position. So I'm going to open up a Civil 3D file that has a Revit file appended to it inside of Navisworks Manage, and then I'm going to show you how to run that clash detection. In Navisworks Manage, I have opened up a Civil 3D drawing directly. That is my Navis B1 Civil drawing. Then I used the append command on the Home tab project panel to add a Revit model to my Navisworks model. And when I select that, you'll see it appear in the model itself. And then I did a units transformation to bring them together in the same coordinates and make sure that they line up. Next thing I want to do is I want to do a clash detection. So on the Home tab, Tools panel, I'm going to click Clash Detective. This will open up a dialog box. From here, I can click Add Test, and I'll select my pipe layers that contain some irrigation lines that I need to check the bridge against to make sure that the bridge is not interfering with any of the existing line work or pipes that are already in the field. Next, I'll grab that Revit model and scroll down in my dialog box to run the test. There it goes. And so you did see it ran a test, and you can see it has 1 clash, and I'll have to go and take care of that clash before I send this off. When you're ready to round trip the files back into InfraWorks 360, you're going to use an IMX file again. When you take it from Civil 3D to InfraWorks using an IMX, those smart Civil 3D objects retain their smart capabilities inside of InfraWorks. And so when you take a surface from Civil 3D, it goes into InfraWorks as a terrain surface. So you don't lose any of that elevation data or triangulation. When you take alignments and profiles across that are not associated with a corridor, they become road center lines on the import, and then they're available to use InfraWorks styles to display them so that you see all the lane markings and asphalt and curb and gutter and everything. Corridors are a little bit more complex, and so when you take a corridor across, you have one of the alignments that are associated with the corridor that come across as an alignment or a road inside of InfraWorks, but then all of the regions from the corridor are going to come across as coverage areas. That way you can see how the finished ground surface looked like in that detailed design very easily. And then finally you can bring across pipe networks, and they become pipes and pipe connectors inside of InfraWorks. The key is when you're importing information from Civil 3D into InfraWorks, you want to configure everything using the IMX tab, and when it comes to corridors, you'll use both road options to use the Civil 3D corridor regions instead of native road styles, and you'll use corridor regions instead of a top surface. That way you get a really nice look when it comes across, because you'll see the top surface of your road come across very clearly. Once it's in InfraWorks, you can visualize the model, you can analyze the model visually, and by adding visual effects to the model, such as turning on high quality visualizations and turning on your ambient occlusion, you can create shadows in the model and reflections off of the waterways, and you can have the light sources actually reflect off of one surface onto another surface, just like they would in the real world. You can also do a couple of different line of sight analysis that help you analyze the model and make sure that you understand how shadows affect the design and where you're going to see certain items and what things are going to be hidden from a specific point of view. So let's actually go into the software and analyze the model using InfraWorks. In order to take the Civil 3D model back over into InfraWorks for visualization and analysis purposes, you'll need to save the file first. So on the Quick Access toolbar, click Save. Then you'll export the IMX file. So you'll go to the Output tab, Export Panel, and click Export IMX. One thing that you'll notice as you export the IMX file is that Civil 3D does not ask you for a file name or a location. What it does is it exports that IMX file to the exact same location as the Civil 3D drawing file is saved, and it uses the Civil 3D drawing name as the IMX name. Now that the IMX has exported, it gives you that information at the command line. I can go over into InfraWorks, and within InfraWorks, I go to the Build, Manage, and Analyze Your Infrastructure Model and Create, Manage Your Model to open up the Data Sources panel. Then within the Data Sources panel, you simply select the File Source options and choose Autodesk IMX. It'll ask you for which IMX you want. You go select it, click Open, and it'll give you the option to import all of those Civil 3D entities. It could be your pipes, your roads, your surfaces, and so on. And so I'm going to just bring across my roads, not my surfaces at this point, and I'll click OK. Now because my roads were corridor models, it knows that it can work with those corridor models. And so I'm going to simply double click on that Civil 3D road file, and under the IMX tab, I'll tell it to use the corridor regions and the corridor top surface instead. So I'll close and refresh that, and once that is done, my road is going to appear inside of my model. If I'd like to change the style that it used with that road, I can go back in and double click on the road itself, and on the style rules, I'll simply select a style of road, click OK, close and refresh that. And now I have exactly what I want. You see the grading that has taken place from Civil 3D, and you see the road style from InfraWorks. Now I can go and do any analysis that I wish. Once you bring the model back into InfraWorks, you can do a visual analysis and a couple of other analysis. Let me shut the data sources panel here. And the first type of analysis you can do is a visual. So if I go to Settings and Utilities and click Visual Effects, you'll see that I can turn my high visual quality to on, and that allows me to see the reflections and shadows in the water. Next, I'll turn on my ambient occlusion, and just watch this area right here. You'll see that you get a lot more shadows and reflections from one surface to another, just like you would in the real world. So that's one type of visual analysis that you can do. Another type would be to go ahead and select the items that you can see from a certain viewpoint. So let me just change my view to a point of the mansion. This is basically a view from the mansion to see if you can see any parts of that road. And from the first view, it doesn't really look like I can see the road, but I'm going to do another type of analysis so that I can see if I really can or not. So if I go to the Build, Manage, and Analyze Your Infrastructure model, and then Analyze the model, you'll notice that I can do a Select Visible, and this will select everything that can be seen from this viewpoint. Then, by simply changing the viewpoint, everything does stay selected, and I can see easily what items can be seen from that viewpoint. I'll hit Escape to get rid of that. Now, another type of a site analysis that you might want to do is a site distance analysis. This is done in the Roadway Design module of InfraWorks 360. So when I click on the Design, Review, and Engineer Roads, and then Review and Modify Roadway Designs, you'll notice that I have a site distance analysis option. By selecting that, it'll ask me to select a design road, so I'll simply select the road that came in from Civil 3D, and now I can tell it what type of summary I want. So do I want to analyze it from the forward direction or backward direction? What side of the road do I want to drive on? Am I in the US and driving on the right side, or somewhere overseas driving on the left side of the road? Where am I? And then which lanes? Basically, lane 1 would be the closest one to the center line. And I'll just click Analyze. I could actually have it tell it to analyze the road decorations as well. Let me just reanalyze that. And according to everything that came up, I can see where I have site failure in this area and clear site in this area. Now, the final piece of the project is creating those high impact visuals. This is really key to not just wait till the end of the project to communicate the design visually, but to actually be communicating it throughout the project. That's because using visualization tools to better communicate the project results early can end up saving millions upon project completion. For instance, if we look at the Legacy Parkway in Utah, this was an 11.5 mile 4-lane freeway that cost taxpayers $685 million due to multiple construction delays from a lawsuit that halted construction over environmental concerns. If they had used high visualization tools to communicate the design to the public much sooner in the process, they could have saved a lot of money. And we learned from this project how extremely important it is to get buy-in for the project from all stakeholders throughout the design process. And that doesn't just mean the people paying for the project, the client that you're hired from, or the government agency that's approving it. It means the public as well. Because if you communicate that design to everyone, they can see very clearly whether or not you're going to harm the environment, whether or not it's going to affect them, if it's in their backyard, are they going to be able to see the traffic, are they going to be able to hear the traffic? All of those things come into play, and so you need to be able to communicate that to everybody. And you can do this in a couple of different ways. One way is to actually create snapshots or renderings of the project, so that you can show everyone what it's going to look like from specific points of view. Then, of course, you can also create slideshows. And slideshows are great ways to create videos to capture what it's going to look like. And you can do this by driving down the corridor, making it look like you drive down the corridor. You can add captions to the storyboards. You can export those storyboards out to a video and place it on a public website where everyone can see what's actually happening. But that by using the storyboards, it enables you to capture and compile views of the model in a slideshow presentation from many different camera angles and simulated paths down the road, and looking at things from neighboring businesses or neighboring residences, so that you can have a very clear picture of what they're going to see when the project is complete, and they'll know how it's going to affect them. When you're creating storyboards, you can actually export them out to video. And that way, like I said, you can share them on a public website for everybody involved to see what's going to happen when you design that project or when you finish that project. And you can export it in a number of different ways. You can use compressed videos, Windows Media Video, the DV video encoder, MJPEG processors. There's a lot of different ways you can export that to video, and different video types you can export to. So let's actually take a look in the software at how we can communicate the design using visual images like snapshots and renderings, as well as create some storyboards. Now I'm ready to start creating images and videos for public meetings. So I'm going to click on the Create Design Presentation icon and select either Create Snapshot, or I can go ahead and render the model. When you render the model, it's going to start rendering the current view, and each pass that it goes over, it's going to get a little bit clearer, a little bit crisper, and you can see that when you have water in the model, it shows the reflection of the buildings or anything else surrounding it. When you have it clear enough and crisp enough for your liking, you simply hit stop and then save it out. And you can save it out as any of the JPEG, PNG, BMP, TIFF, HDR. Now, to create a video, you'll actually use storyboards. So again, you'd go to Create Design Presentation, and you'll click Storyboard Creator. From here, the storyboards are really nice because you can make it look like you're driving down the design road, or you can crane up and look around and just look at the model from different views and have it look like you're in the model taking a picture or videotaping with drones or whatever. So let's actually see how we would go about creating that. Now, I'm going to create a new road, if you will. So I'm going to just change my view here. I'm going to create a design road going down this waterway. And it does have to be a design road for what I want to do. But let me just quickly create a new storyboard. So in the storyboard panel, I'm going to click Create New or Add New Storyboard. Then I'm going to create a design road. I'm just going to do a local road. That looks good. And I'll quickly add in some points here. Maybe increase my curve radius by quite a lot. Make sure that it stays, close to the center of the channel, if you will. And I'll end it right about there. Now that I have a design road where I want to create a path animation, I'll just go in and choose to create a camera path. And I'm going to do it from a design road. It's going to ask me to select that design road, so I simply select it. Now that I have the path in there, I can preview it, or I can go ahead and delete my road if I know I'm done with it, if I want to delete it. It might be the road that you've designed and you want to keep it. I'm going to simply hit play and see what that looks like. Now, if I'd like to add other animations, or if I want to make any changes to my animations, I can do that very easily by selecting any of the keyframes. And then the keyframe properties are over here on the right. I can go directly to that keyframe and make changes to it. I can change the speed. I can change what it's looking at. If I want to interpolate a focus point, I'll just turn my camera that angle and reset it. And that way, as I drive by that point, it'll begin to look at it and then look away as I drive past. So let's actually see what that looks like. So it started by looking at it, and now it's looking down the path again because I'm not looking at that point anymore. To change where you're actually working in the model or in the storyboard, you'll just use your cursor to move the playhead, or you can move the edit head as well by using your cursor to drag it. If I'd like to go to the end of my storyboard, I can double click and both the playhead and edit head will move to that location. And then I can add additional things. Maybe I want to add a crane animation. Whatever the case might be, I can add all of this information and then I can quickly play that to see what it looks like. Even though Autodesk InfraWorks does a great job of helping people visualize the project, you may find that you need a little bit more detail that you'd like to take it into 3ds Max Design. And while the Autodesk 3ds Max Design software has a robust 2D and 3D modeling system, many users find it most efficient to link or import some or all of their design data from other applications. This is especially the case if the bulk of the design work is completed in other Autodesk software, such as AutoCAD Civil 3D. It's recommended that you import 3D ground surfaces from survey and civil products, such as AutoCAD Civil 3D, using the VSP 3D data format. The import process involves using Civil View inside of the Autodesk 3ds Max Design software. So what you'll do is take it from Civil 3D by exporting out to the VSP 3D data format and then import that into Autodesk 3ds Max Design and view it and make any corrections as necessary. So let's actually take a look at how we take it from Civil 3D into 3ds Max. Before you can take the design into 3ds Max, you do need to make sure that all of your surfaces are set up correctly. So let's just zoom in to this site and take a look at what we have. You'll notice that when I select this surface, it is a grading surface just for this island. Then when I zoom in closer, you'll see that there's a curb surface as well. You do need to make sure that each of your surfaces for the different types of material are all set up. And you also can make sure that happens by just selecting that surface and going to the surface properties, and then set the render material appropriately. Once everything is set up properly and you have all of your different surfaces created, then you'll go ahead and export that to 3ds Max. You'll do that on the Output tab, Export, and Export to 3ds Max. One thing I want you to be aware of, though, is if you have corridors in here, you'll need to rebuild those corridors before it allows you to select them. So let me hit Cancel, and when I expand corridors, you'll notice there's an exclamation mark. I'll simply right-click, choose Rebuild, and then back on the Output tab, Export Panel, I'll click Export to 3ds Max Design. This time it's going to allow me to select that road surface, then I can select any of the other surfaces that I wish to use and click Export. Then I simply tell it where I want it to be at, and if I have one already, I can replace it. And then I'm ready to go into 3ds Max to import it. Once you bring the model into 3ds Max and do a little bit of cleanup, you'll see that you get a really nice clean site. And in fact, when I zoom in on my model, you'll see that all of the different surfaces have the appropriate materials. But like I said, you do have to do a little bit of cleanup, so let's take a look at that. I'm going to create a new model without saving anything. Then I'm going to bring in that VSP file. So I'm going to click on Civil View. And if this is the first time that you've touched Civil View, you may have to initialize it and then start it. And then, of course, I brought up my Civil View Explorer using the Civil View Explorer option. Now I'm ready to import my geometry. So I'll go to Geometry Import, Civil 3D File, and I'll choose to open a file and then select where that's coming from. Now that the file is in there, I need to tell it what to actually bring across. So I do want to bring in all of my surfaces. So I'm going to select Surfaces, and then using my Shift key, I'll select the top surface, and then select the bottom surface with the Shift held down, and then I can check mark all of them at once. Next thing I need to do is bring across my corridor model. Now, I don't want to bring in all of the feature lines, but I do want to bring in each of my different regions. So I'm going to bring in my primary access, and then regions 1, 2, and 3, and then click OK. It's just a little bit of information here. Click yes, that's fine, and yes again. When it's done, you'll see the model appear. One thing you'll notice though is the corridor model will look good, but the other surfaces are not quite set up properly. So we need to go in and set those up. To change what we see here, we'll go into the Civil View Explorer, and we can start by selecting one of the surfaces in the model. And you'll notice that it selects it down here under the object list. And this is the C-Topo building pad. And so now I need to just change that slightly. So I'm going to go to the Statistics tab. And since I can't see quite everything, I need to just scroll down a little bit. And then I can right-click on my ground surface and modify the material ID. Yes, I'm okay with that. And now I tell it what I want that to look like. So I want it to be a concrete style, and you'll see it gives me a preview. I click OK, and it is updated to that concrete. I would just go around doing the same thing with each of the surfaces. So now I've got my topo outside. Again, I go to the Statistics tab, scroll down a little bit so I can see my material ID. I'm going to right-click, modify that material ID, and then select an appropriate style. And it's that easy to set up your model. If you've watched this recording all the way through, I definitely want to thank you for your time, and I hope you found it very, very valuable. I really enjoy teaching at Autodesk University, and I felt bad that I couldn't make it this year, but hopefully you found this recording valuable, and if you did, definitely send me your feedback to mrasmussen@rand.com. Now, everything that I've taught you in this class has been based off of my BIM Workflow for Roads and Highways manual that I've written, and the thing about that book is it will help you prepare for the certification exam. Each of the certification topics are listed at the beginning of the sections that they are covered in, and they also have section learning objectives so that you can see what you should be learning in that section beyond just the certification. At the end of each chapter, there's also chapter summaries or command summaries. And these are great little reference sheets that you can copy and paste up on your cubicle to help you find very quickly the commands that you use the most often. Another great thing about the book is it helps you reinforce learning. At the end of each chapter, there are chapter review questions that'll help reinforce what you've learned, as well as practice exercises that you'll be able to go and walk through step by step everything that I have done here today and a lot more. It'll actually go through the InfraWorks software in the first 4 chapters. It'll go through the Civil 3D corridor modeling and a little bit of advanced information in there where you'll be able to build a corridor with multiple baselines, multiple regions, and you'll actually be able to add super elevation data to it as well. If you were at Autodesk University, you heard it from Carl on the main stage that Autodesk is now providing free access to Autodesk design software and apps to students and academic institutions worldwide. This includes full versions of the Autodesk software. It's the same software that the professionals used. And Autodesk does this because they believe the next generation will create a better world, and they want to inspire a love of design and equip the students of all ages to become engineers, architects, and digital artists. That's why Autodesk provides free access to professional Autodesk design software and apps to students and academic institutions. So definitely, if you're a student or an educator, take advantage of that by going into the website autodesk.com/education and download your free software now. Thanks again, and hopefully I'll be able to see you at the next Autodesk University.